Okay, my research objective is to find an innovative way of protecting against the evolving threats for the game server. Right, so you see that all those evolving threats like the Web3 related, DDoS related, bot related. So if you're still using the traditional way of blocking it, we're going to face a lot of challenges, especially for those like zero-day attacks. Right, so that we have to leverage those like AI and machine learning, the large language model to get them detected, and some of the innovative approach leveraging those like SDK-based kind of solution. So over here, this is the list of the components I've used to build the lab, like the Cloud SOC, Cloud Audit, Cloud Firewall, and also something that I built innovatively leveraging the large language model, the Web3-based monitoring for risk model, right? And over here, this is the high-level overview of my lab setup. I have the lab being set up on the commercial cloud. I have the front embed and DB built-in installed with the cloud workload protection engine. And also I have the WAF, anti-DDoS, and edge security built-in at the key management system so that I don't have to hardcode my secret into my code. Right? And I have the visibility tools to make sure that I don't have my credentials being leaked. And how the anti-DDoS works over here, right? So have the mix of the layer 4 and layer 7 attack traffic, basically some volumetric traffic, getting into my cloud environment. I'm going to block them using the AI and machine learning and also the signature, the pattern-based, the traditional approach. On top of that, I'm going to use the watermarking SDK to block this traffic without a legitimate watermark being generated. And also I have to select those attack block node that is nearest to the attack source instead of the origin server. So how it works over here is I have my SDK integrated each of the game clients, so each of the traffic packet being generated will be embedded with the watermark into the UDP or TCP headers of it. Right, so the offset byte over here is just to tell the engine where I should look up my watermarks, right? And how I ensure the watermark is being up to date will not be easily interpreted by the hacker is through the key delivery or key rotation, right? So I can do the key rotation on the local device, but it's highly insecure, right? Because the hacker can easily reverse engineer my code and they try to find out how for example, the key is generated, key is rotated, so they can easily leverage an expiry key to do the packet replay attack. So instead, basically, I built my key rotation algorithm on the server, on the cloud-based server, on the back end, right, where the hacker no have the direct access of that. So whenever the game client is launched, and then a query to the cloud server, and then get the latest key, and then generate the watermark. So whatever traffic without the legitimate watermark will be rejected by the cloud edge, right? So I can make sure the 100% efficacy of it. So basically, the app that I built for the demonstration is to print out the package structure of the packet that is consisted or is containing the watermark over here. I see that the first 12 bytes of it actually is almost the same, but the last 8 bytes is always different, right? You have the order numbers over here, and also you have the dynamic value being generated based on the game set DLL files. Right, so DLL files is repeating my algorithm will generate the same algorithm to identify it on the cloud as well. So over here, this particular DLL file is encrypted, right? Is obfuscated, right? And with the key being rotated, so these two will be generating my watermarks over here. And comparing with the traditional way of doing that, right? So traditional way of detecting the DDoS attack, you always yield with a high false positive and false negative rate. But with mine, some of the considerations, for example, I can do the manual rotation of the key, right? But it will always be done to, for example, every release cycle of my game client, right? But it's not automated, but it's acceptable, right? The other way is using the automated rotation, either locally or through the cloud delivery. I prefer to do it through the cloud delivery, right? So these are some of the considerations. And not all the traffic requires the watermark, right? So only very sensitive, time-sensitive traffic from the FPS games that requires. So of course, I don't want to basically overload my server, right? The detection engine as well. Cause to identify the watermarks, it's always like CPU memory intensive. So I have to select, for example, from what range of the UDP traffic or range of the TCP traffic that requires a watermark. And also, I always keep the watermark keys 2 active at a time, right? So that one is facing out, I still have the second one to use, and then I add in the third one, right? So that I can make sure there's no downtime during the key rotation. And over here, I should always make sure that my latest key is curable through the online API. So here is a quick demonstration of it, right? So for the full demonstration, you can just walk through my progress report. So basically, this is the source code of it. I see that I have my game.set.dll files over here. And the reason I built this app C++ as just to print it out, showing you how the package structure looks over here, right? So over here, the UDP TCP port, I just randomly define it so that it can still generate the packet. So once I run the application, so you see that first 12 byte is always the same, but the last 8 byte keeps changing, right? So over here is done according to the key as well as the latest game.set algorithm or the watermark generation algorithm. So the last 4 byte is a sequence number, so I can easily trace back whenever there's a, for example, false positive or false negative. And the next is just a walkthrough of some of the best practice on the cloud using the commercial cloud security components, like the cloud workload protection solutions that have the scoring, have the benchmark, the vulnerability scanning, and the cloud firewall. I simulated some attacks like cross-site scripting, sensitive file access so that I can get them blocked, and the data security center, so I can add some of the pattern regress to make sure that my credentials, my personal details won't be leaked, right? Whenever there's a leakage of them, will be blocked by this data security center. And the cloud audit, so you know that who, where, why, and how, right? They operate, they interact with the cloud portal. And the cloud SOC or the cloud SIEM, so basically it's ingesting all the logs from different cloud components like the cloud firewalls, like the cloud virtual machines, so that it can correlate and tell you any of the potential threats. So the second demo of it is leveraging the large language model to detect those like malicious HTTP requests. So over here, I'm using bots. And the other one is to monitor the main chain of Ethereum so that I can detect whether there's any suspicious transaction of their Ethereums or the cryptocurrency or the wallet, right? Because nowadays all the games going Web3 so that the gamers can easily transact their in-game asset to monetize them, to commercialize them, right? So basically this it should be considered basically a new, I would say, a horizon of the attack vectors. So the full demos of it will be available here. So for the sake of the time, so basically this is the first script that built to monitor any of the, for example, the large amount of a transaction on Ethereum, any of the suspicious one. And the second one is the code to detect any of the suspicious requests that will be sent from the HTTP server. So over here, the attribute code is leveraging the large language module. So you see that the source code don't contain any of the static rules, static signature patterns of it. Instead of just using the large language model, right? And then I'm going to come back telling you that with this chunk of or this list of the HTTP requests that contains sources like, for example, admin -- user ID equals 1234, right? Basically cross-site scripting, basically this embedded with the script. So basically with list of them will be detected as a suspicious, malicious with the confidence levels over here, right? So basically that is using the ALM, right, to detect them instead of using pattern-based, signature-based static rules of it. So the benefits of having that is to detect the future zero-day attack with zero pattern signature being identified at that time, right? And the next is the SDK-based kind of protection, right? So that the SDK is client security. I can detect whether it's a bot or a human, I can apply it to different kind of use cases like wallet top-up, account logging, and on the back end, I'm going to come back with the risk score or the risk code. And these are the factors, environmental factors of the device will be taken into consideration, whether the device is in developer mode, whether the device is being rooted or jailbreak, and how it interact with the edge is that on the client side, right? So after I pass the capture check, make sure that a human, I receive the ticket, a random string over here, right? Later, I'm going to explain why I put a random string over here. And then I'm going to send HTTP traffic with this ticket to the edge, and the edge is going to translate it with the risk code and then send the clean traffic to the server. So over here, how it works is client side, I pass it and receive the ticket, right? And then I send the HTTP request to the Cloud Edge. And then on the Cloud Edge, once I have the ticket, I'm going to exchange with the Cloud API and then get the risk code. And then I'm going to block based on the risk code I'm getting. So over here, I've written the Edge function. Basically, it's serverless function code using the JavaScript. And on the client side, I have the SDK being integrated, right? So the demonstration of it is available through update 4 of mine, the full demos of it. And okay, so basically this is the source code of mine. And I have this detection engine being built in since I'm using the emulator, so by default it's popping up, right? Because emulator is considered suspicious, high risk, so that I have to pop up the capture to make sure that I'm human. And once I pass that, I have the ticket, right? Which basically is a random string. Why I just don't tell the device to return with the risk code over here? Because it's vulnerable for the modification by the hacker, right? They can intercept and they change the risk code in the sandbox so that on the server side, basically there's no way to tell whether it's a true positive or false positive, right? So this is one of the consideration. And on the server side, right? So once I receive the random string of the ticket, I have to write a function basically to exchange this particular ticket with the random string with a particular risk code. Once I receive the risk code, and then I'm going to block the risk code with corresponding actions over here, right? So risk code like 101, 201, 301, etc. So basically this is how it works. And the next one is leveraging those like open source model building platform to build my own fraudster or risk detection model, so that the model is highly customized for my game environment, my clients. And the methodology I'm using is, of course, I'm collecting the behavior insights, data infusion, feature optimization with the data I use for training, and then I'm going to implement or deploy the model that I've trained earlier to an open source decision engine. So whatever requests coming in, I'm going to vet through it. So the full demos will be available on here as well. So just quickly go through it. So over here, it's using the AutoML pipeline. So we have the data input. We select 70% of training, 30% of validations, and then we're going to the feature engineering. So I've done the feature engineering as well. So over here, we're going to select some of the feature that is required for the training or not. And then I'm going to select what algorithm I'm going to use, right? So over here, I'm going to use the standard logistic regression, so you can easily do the benefit classifications very effectively. And then I'm going to assess the model that I trained earlier, right? Since, I'm building it for demo purpose, I'm just using the perfect set of data. So AUC is 1, basically it's 100% accuracy, right? And the KS value is also quite high. So after I train models, I'm going to implement it like a decision flows over here. I'm going to like test this particular fraud models. I input all those like user details, and I'm going to get the result of it, right? So basically, this is a quick demonstration of it. And alternatively, I've also built a external database, because you're not just querying for your model, but also you're querying for some external, for example, the sanction list check. For example, the user want to transact is their in-game asset. For example, the gamer is using that for the money laundry. I should check whether this particular user is under the current international sanction list. So I built a mock-up sanction list database, and I query externally, and I see myself is not sanctioned. But if I have to query, for example, someone else, wait a second, this is just the server I built. And if I'm going to query, for example, Jack is considered sanctioned, right? So basically, this is leveraging the intelligent decision engine. Okay, here is some of the evaluation criteria. So successfully building a working demo from embed and edge API security, right? AI detection for those like commonly known attacks, even leverage the large language model, right? Web3 monitoring is really necessary, because now most all the games have its own Web3 arms of it. SDK based, because I always have my game client be installed. So why not, right? Just build SDK into my game client to get more data for the analytics. And last one is to verify whether there's any other device farm or the bot, right, being used, so I can implement a capture and also get this particular risk code integrated with the edge function, so that I can block based on the risk levels of this particular device. And some of the limitations of here, of course, false positive, false negative, leveraging the AI, we should keep improving that. Of course, blockchain has its own limitations. For example, like 25 transactions per second for the Ethereum main chain. So, I mean, if it's monitoring tool, it will face the limitation as well, right? And also the risk models, they need to be retrained on a timely basis. And also for the different type of the game engines like Unity or different kind of front end like Flutter, I need to customize my SDK into their way of basically, it has to be like Flutter native. It has to be adapted to different kind of mobile development framework, right? And also to sync the AI score and also in-game risk response. For example, I detect this particular players consider high risk score. However, whether I should reject them immediately or 10 minutes later, right? So basically, these are some of the limitations or the considerations. And the future works, right? So of course, that implement more AIs, adding different kind of database like graph database into it, so that I can know better of the relations. Training models like cross the different users leverage their own sensitive data using the federated learning. So the user, the players, when they turn in the data to me, they have no concerns at all, because the federated learning is that I use that sensitive data to train the model, but I don't know what exactly the data is. So basically, that's the beauty of having the federated learning. And also some of the adversarial attacks to the AI models to make it more robust. Get more like players biometrics data being ingested, and also create easy to use SDK that is catered for different type of the gaming engine. So that's all. Thank you very much.